Hello and welcome to part 4 of the Pixel Soccer Global Tournament making of. Today, as I told you, we'll have a look at the very first simple drawing operations and why we should always use double buffering, at least double buffering. Well, it's pretty simple to print something in Visual Basic. To print, for example, a rectangle onto your window. This is what we'll do first. Now here where we did put in the commentary of a redraw window, we'll go here and just use the line method, line, to print a rect that moves around the screen for a bit. So for example, it should start at the left side and it should move from left to right. Never change size. So we have to put in the starting coordinates. So we say start on the left side and on the top, and it shall go to screen punct width screen height 3. So it shall be 1/3 of the screen, and then we have to input the color, which will be red, and it shall be filled and it shall have a border of the same color. So, oh sorry, it's BF, not FB, yeah. So, what this will do is it will draw a rect, always in the same positions from 0, 0 to screen width third and screen height third. We want it to move so we can see an effect better that will explain to us why we need the double buffering. So therefore, we will put a variable here, dim start x as single. Since we are calculating in TWIPs, they are always in single format. I don't know why, but it is like that. And this 0 initially, so we put start x here and we put start x here, and then we will just screen TWIPs per pixel x. Yes, this plus. Okay, so this will basically mean that it will move 1 pixel per step from left to right, and yeah, let's just see what happens. Okay, so it's moving to the right, it's moving, it's moving, it's moving. But here you see the first issue. What you drew on the screen earlier will not go away by itself. That basically means you have to clear the screen, or the bitmap that is used to view the screen, if you redraw it. So this basically means we have to do clear screen before we draw. This will solve our issue, and so we see that's pretty easy to draw, isn't it? So let's see what happens now that we clear screen before we redraw something. And now you see what happens. It's flickering, because after you clear the screen is repainted at once, and therefore this creates this flickering, because the screen is gray, then it is red, the screen is gray, then it is red, and this is flickering like hell. So this is not very good looking, is it? I mean, it's just annoying, and it hurts your eyes in the long run. And if you imagine a game where a rectangle is running around your window and you try to catch it and it's flickering like crazy, that's not pretty cool. And therefore we use double buffering. What does double buffering do? Well, for short, it means that all the drawing operations you do, you draw into a bitmap that is saved into memory, and that you actually never see. And after you drew everything you wanted to draw in your next drawing phase, you project the whole bitmap onto your window. Therefore, you will only redraw your window once, and so it has no chance to actually flicker. And unfortunately, this will be a bit more complicated. We will dive deep into Windows APA right now, and I hope you're ready for this. We'll need some API, and we will probably have some fun. And I hope you understand everything I try to explain. We'll start off by deleting this code. We don't need it anymore. Don't need this either. Okay. On a side note, you see that, as I said, if you're actually doing something inside the loop, the frame rate will drop. Now it's down to 45, which is still pretty cool. Everything above 40 is okay. We will have the chance to play around with our sleep later on, but this will only happen when we have to control the speed of our game. Right now we don't care. So, drawing, we will use the GDI APIs to draw, and there are many of those, and they are very useful. So, of course, what do we need to draw? In Windows, if you want to draw something onto a bitmap, the bitmap has to be selected into a device context, a DC for short, and therefore we need APIs to create a DC. Luckily, our window always has a DC, so if we put here me d hdc, we'll get a DC handle, and we'll use that later. But for drawing ourselves we need another DC. Therefore we will take the API create compatible DC, and whenever we use a DC we have to delete it later. So we see delete DC. So we'll be able to create a compatible DC, compatible to our window of course, and delete it after we are exiting our program, or when we're exiting our program. Of course, as I said, we will need a bitmap in memory. There is a create compatible bitmap function, which will allow us to create a bitmap that is compatible to a DC. As you see here, it will ask for a DC and it will create a compatible bitmap for this DC. We can also use the window DC here. And if we do not use the bitmap anymore, we'll have to delete this also. So we put here delete object. So this means after we do not use the bitmap anymore, we will delete it. So what else do we need? Of course we need a function that lets us draw a rectangle, and there is a function called fillRect, and as you see down here it uses a structure of type rect, so we will have to import this also. We'll catch that later, fillRect, and you see that it wants a brush, a handle to a brush as long. A brush basically is a form of drawing into the rect. So it can be a solid brush, it can be like a brush with certain effects on it. For us, for now, we'll need a solid brush, and this we can get with create solid brush. So now we create a DC, we create a bitmap, then we have every DC is already generated with a bitmap of size 1 by 1 inside. To replace that, we need to select object, to select our bitmap into the DC that we create, and to play around with it. As I said, fill rect will need us to create a brush to give it the rect. And after we have drawn, we need to get our bitmap from the memory into our window. And that is done by the bitBLT function, which will completely copy the bitmap into the window bitmap that is used to show the window. And we will need the rect type. So we go to types and type rect. There it is. So those are the APIs that we will need. Let's cut this out and insert it here. So the rect is here at the end. It doesn't matter really too much, but most programming languages want types and constants declared before you use them. So normally you should always start with your constant values, then with your types, and then with your declarations of functions. So I copy it to the top. Okay, so let's dig into that now. As I said, we will need an HDC for our buffering. Handle values are always, or most of the time, handled as long in Visual Basic. We will need a bitmap as long. We will need another bitmap handle. This will be the bitmap that is originally created in the DC and that we will replace by our own bitmap. We save the handle because you should always reset the bitmap to the DC before destroying it, so there is no memory leak or anything like that. Okay, so we can start by creating a DC is create compatible DC to our window DC. Then we will create a compatible bitmap to our window DC. So then we will, as I said before, we will save the original bitmap and select our own bitmap into the buffer DC. Okay, and at the end we will just say, hey, we reselect the original bitmap back, and then delete object our buffer bitmap, and then delete DC the buffer DC. Okay, so that's the first steps. So we create a DC, create a bitmap, select the bitmap, and delete everything after we exit our program, or when we exit our program. And as I said before, what else do we need? We will need brushes. So let's create some brushes. Let's create a white brush for the background, white as long, and a red brush for our rectangle, like this. And we will create them. Create solid brush, and Visual Basic has neat little color constants, so we will do VB white, and then basically red brush VB red, and those brushes will also get destroyed down here by brush white and brush red, so that nothing remains in memory after we exit the program. Okay, so now we have the brushes and we have selected the bitmap, and now of course we need to fill rects. That means we will have to fill the complete rect with a white color and a white brush. Okay. Now as you see, we need a rectangle that is supposed to be filled, so we will create a rectangle that is just covering our whole bitmap. That means we will just dim rect window as rect with rect window. Left and right, left and top, of course, will be 0 and 0, since obviously those are the starting coordinates, and bottom and right will be me width divided by screen twips per pixel x, and me bottom will be me height divided by twips per pixel epsilon. Of course, since Windows API, if it's not mouse API, but normally drawing API at least, will always work with pixels. So we will divide the twips by the pixel, twips per pixel, and we will get pixels, of course. So now we have a simple way of clearing everything in our window by just painting the whole window white and rect window. So now the next thing we need, of course, will be a rect that draws our actual red rectangle that moves on the screen, of course. So we create another rect. We call it rect. And rect starts at the top, so top remains 0. Left, on the other hand, also remains 0 because it starts on the top left. Right will be, I think we took 1/3 of the screen, so we do by 3, and bottom also by 3, divided by 3. And yeah, this will be what our rect looks like. Of course, we will basically fill rect right after we cleared everything with rect and a red brush. Red, like this. Okay. So now we have painted the rectangle, and then we have to move the coordinates of the rectangle, of course, by just adding 1 pixel. Oh. And width, of course. Of course, add 1 pixel to the left, and missing dot here. Okay. So, since it is the coordinates of the rectangle, we also have to shift right, or our rectangle will shrink with every step. So we redraw the whole stuff, and then we move it, shift it for the next step, and so now we have to copy our completely redrawn memory bitmap onto our window. And as I told you before, this is done with the bitblt function. The destination window, of course, is me hdc, and it will start at 0, 0, and of course, as we said, it will be me width, no, not any button of me width by screen twips per pixel x, and me height divided by screen twips per pixel epsilon. And the source DC is, of course, our buffer DC, and it will also start at 0, 0, and this constant tells the bitblt function what it is supposed to do. You can do a lot of stuff with that. I mean, you can, for example, make transparent regions and stuff like that, but we want to copy our complete bitmap without anything multiplying, demultiplying, or whatever it can do. And there is actually a constant for that, and the constant is VB src copy. Alright, there we go. Okay, so this should now be enough to get the same effect as we earlier got with 2 lines of really Visual Basic code, but now it won't flicker. Hopefully, we'll see. And okay, I'm now pressing the start button, and let's pray. Oh, what happened here? Oh, of course. Oh, I forgot to actually give the size of the bitmap. So, me width by screen 12 pixel x and me height by screen 12 pixel epsilon. Okay, so that was expected. Let's retry. And you see, it's moving as the other one did, but there's no flickering. So this is why you use double buffering instead of just drawing into the window directly. And you see, it stresses the CPU a bit more. So instead of 45 frames with the Visual Basic commands, we now have 39. But it's still alright, and I mean, I didn't look to make this effective. I just wanted to somehow show you the difference. And I think it worked out pretty well. It was exactly like we expected. If you just clear the window and redraw, it's flickering like crazy. I think I made a test earlier, and I think it's pretty good to see even on video. And now you see that there's nothing flickering. I mean, it just basically moves around into the middle of the screen, and nothing's flickering, and it's pretty neat and pretty smooth. And this is what we want for our game. So now I hope I could relate to you the general meaning behind double buffering. Triple buffering is a bit more complicated, but not that much more, but we won't need it for the game, and you can read about it on the internet. Just Google it, triple buffering and double buffering and stuff. You can inform yourself, but I think it's clear why one would use it. And I hope you enjoyed it, and next time, well, to be honest, I don't know by now what we'll talk about next time, but it will probably have to do with our first tries to get real objects drawn into our window. You should be excited. I am pretty much. You should give a thumbs up if you liked it and if you enjoyed it, and I hope you keep on watching the videos. And well, till next time, bye.